W4, reflection, refraction and diffraction. This lesson is about the general terminology of these things and just learning the words and the basics about them. We will look at each one in a bit more detail in the following lessons. So first one is reflection. When a wave hits a barrier, it's reflected. And we're used to that. Mirrors are an obvious example. If you actually do some measurements of light or any wave coming onto a barrier and then reflecting off it, and you measure what's called the angle of incidence and the angle of reflection, then you find that they are equal. So that's a general rule, that the angle of incidence equals the angle of reflection. The main issue to notice here is that the angles are between the rays and the normal, that's the perpendicular line to the surface, and not between the ray and the surface itself. So I equals R. The second thing is refraction, and this is when a wave crosses a boundary into a different material. When the speed of the wave changes, it means the wavelength also changes. The frequency is still the same. You're getting the same number of waves hitting and travelling through the space per second, but a reduced speed means a reduced wavelength, an increased speed means an increased wavelength. So here's a ray travelling from one medium into another. If we construct the normal again to the surface, the boundary this time between the two, and measure the angle going in and the angle going out. This time the R stands for refraction rather than reflection, but it's still I for incidence. As a general rule, with measurements, we find that the smaller angle is on the side where the wave travels more slowly, but we will look at that in more detail in later lessons. So that's refraction. The third thing on the list was diffraction, and this is when a wave passes through a narrow gap and it spreads out. So here's a wave, well, in this case a light wave, a ray of light. So if we put a screen in front of the beam of light to catch it arriving, and we look at the screen, we would see in this case a small dot where the beam of light is hitting the screen. If this is a narrow beam, so if we then introduce a narrow slit for the beam to go through, you might think that you get a smaller spot if the gap in the here is smaller than the actual beam. You might expect less to arrive on the screen here. But what actually happens is that the beam spreads out. So what you see is a sort of larger, fuzzier spot, which is sort of not what you'd expect logically, I suppose. But that's diffraction. Basically means spreading out. Now, you can affect the amount they spread out, and they spread out more when you make the gap narrower, which again is sort of the opposite of what you might expect, or when the wavelength is longer, and that's something we'll investigate again in a future lesson. So, in conclusion, the three key words here: reflection, refraction, and diffraction. You need to know the difference. You need to be able to instantly say what you're talking about associated with each of those words.